right. So this lesson is over systems. Now, again, as you guys probably know with systems from Algebra 1, this is one of the ones that a lot of people struggle with in Algebra 1, or it's one of the harder ones from Algebra 1. You can get really in-depth with this. Today, we are not going to go that far in depth. So again, remember, this whole chapter, my whole goal is that I'm just hitting the basics of all these. Graphing and substitution, I guess maybe those are similar or similar to what we're going to go over. Elimination, we'll go super far into. And again, later on this year, I don't remember if it's chapter like 3 or 4, we will go over a whole lesson or a whole chapter over systems, and we will go into more depth and we'll get into it. But the whole idea, again, is that we get some review, but we also get that foundation. So if you don't remember this stuff, that's fine. That's why we're going over it, but it will help for later. So the first thing I want to make sure I mention is that any system you have, you can solve it any of these ways. If you really like elimination and you want to set every single one up for elimination, I don't remember. I don't remember on the test what I did. Occasionally, I'll tell you to use elimination, but sometimes I just say solve this one, and you can use whichever way you want. Specifically, solve using elimination or solve using substitution. The reason I'm telling you that is because that's the easiest way to do it. I'm trying to that. So all these methods can be solved all these problems can be solved with any method. The only reason I said, like for graphing, it says use when both in slope intercept form. That's because that's the easiest way to do it. And that's what you need to set them up as. Or that's what I would recommend. So for graphing, we're not really going to get into this too much. I'm not going to do a lot of these. We're just going to do this one example, move on, because it's really not any different than the graphing problems we did before. The only difference is now we're going to do 2 of them on one graph, and we're going to see where they intersect. So I'm going to graph this one first. My intercept is -3, and my slope is up 1 over 4. Now, really, you only need those 2 ordered pairs to make a line. But remember, now we're going to see where they cross. And so if I were you, either I would use a straight edge or I would do my slope a couple more times just to make sure it's straight. So I'd go up 1 over 4 again, which is a little bit off my graph, which is fine. But then I'd also go, instead of up and to the right, I'd go down and to the left 4. Now, again, you do not have to do that, but I think that helps to make sure you have the exact ordered pair where they intersect. One, -x plus 2, so +2 is the y-intercept. -x means it's -1, which is -1 over 1, so you go down 1 over 1. So again, if I went down 1 over 1 and I drew this line, I might, if I curve it at all, I might miss the ordered pair, and so I just do that slope a couple other times until I hit that other line. And again, if you want to use a straight edge, you can, but that's always my hint or my extra help with this one, is that I do the slope a couple times until I can get that exact point that they intersect. That's not your answer yet. Your answer is pair here. So the ordered pair where they intersect, you go over to the right 4, and we go down 2. So 4, -2. The x always comes first, just like the alphabet. A lot of people, not a lot, but certainly more than a lot of you guys would think, mess that up and put the -2 first. Now, you do not have to do this extra part, but I'm going to show you just so it relates to the other ones. That's the same thing as if you got x is equal to 4 and y is equal to -2. And again, you'll see why I put that up there on this next one. But again, ultimately, you're just graphing a line. You're just doing 2 lines on one graph. It's not too much more difficult than that. Any questions on that? So moving on to substitution. So substitution, I use this, or again, the time that you can or you want to use this is when you have one of your equations that has one of the variables all by itself. So if you look at number 2 and 3, number 2 has the y all by itself in the first equation, the x all by itself in this first equation. That's when it's a good idea to use this. Now again, if you want to use this other times, you can manipulate your equations so that you have the x or the y by itself. But this is the time that is the easiest to use this. This in here to give you a little bit of background that will help you guys out. And I kind of explain how to do it here. Solve one equation for a variable that we already have done. Then you're going to sub the equation into the variable in the other equation. So what I mean by that is, remember, if we have y is equal to 3, that means I can plug 3 in every time I see a y. Because if they're equal to each other, they mean the same thing. So the analogy I always use is if I had like a bunch of wood I have 25 pounds of wood over here, and I'm trying to balance that out. So I have a 25-pound, I put a 25-pound rock on this side. Well, if I took that 25-pound rock off and I put a 25-pound piece of wood, it'll be balanced. That means they're the same. I can take one out and put the other one in. If they all weigh 25 pounds, it doesn't matter which one's in there. You can take one out. Equal to 3, you can put that 3 in for that, and that's great. That's what that means. Hopefully you guys all remember that. That's just normal when you sub in a variable. However, now, instead of a 3, we have this whole equation, y is equal to negative 3x plus 5. But the rules don't change, and that's why I like math. The rule doesn't change. Whether it's y is equal to 3 or y is equal to negative 3x plus 5, that means they're the exact same. So anytime I have a y, I can replace it with a negative 3x plus 5. One of my other analogies with this one is if you have 2 tuba players in the marching band, and they both are the exact same level. One of them's marching, and for whatever reason he can't make it. You can take him out and put the other tuba in, and everything's okay. Everything is the same. That's the same thing with this. So this y, take that out. So 5x minus 4, and instead of y, I take that completely out of there, and I put in negative 3x plus 5. Equals negative 3. So again, I took that y totally out. If you don't take it out, because a lot of people accidentally do that, they put they just put the negative 3x plus 5, they put it beside the y. If you have x's and y's, you're not going to be able to solve. The whole idea of this substitution is that in this next step, we only have x's, so now we know how to solve that. So now is where you have to do a little bit of legwork, and this is something that you say you're bad at math. Yes, this one's going to be. There's a lot of solving with this and a lot of steps. Analogies, or one of the things I was talking about earlier, where each step isn't really too bad. So distribute the 4. X, negative 4 times negative 3 is positive 12x. 5 is negative 20. 5x plus 12 is 17x. is equal to 20 to both sides. 17x is equal to 17. Last but not least, divide both sides by 17. We're going to get an x is equal to 1. So that's how we find one of the variables, but we're looking for both variables. We need an x and a y. Just like the graphing problem we had before this, we had an x and a y. So for this one, and for elimination, once you have one of the variables, you plug it back in to find what the other variable is. So plug it back in and solve, and it doesn't actually matter which equation you do. You can plug one into this one and solve, that's great. It's going to be the easiest way to plug it into the one with the variable by itself. Again, you don't have to, but that will be the easiest way. So I have y 3 times 1 plus 5. Whenever you plug anything in, I would use parentheses, and I wish, I was thinking the other day, I should have done a substitution problem somewhere, or just had a sub numbers in, but it's a good idea to use parentheses. We'll talk about that later. Negative 1 is negative 3, 5, negative 3 is 2. So my y is 2. Like that, it's absolutely fine. However, just to make it an ordered pair, so it looks like the graphing problem, you get 1, positive 2. On the homework check, that's how I had the answers. I have all ordered pairs because that's just what's easier for me to type up. Now again, I know that problem takes a while, but each step really isn't too bad. We did substitution, we actually subbed it in. That's just multiplication. Terms, that's just adding. We added 20 to both sides, divided by 17, it wasn't terrible. Again, there's just a lot of steps to that. Same thing with the next one. Now we just have x is equal to something, so I'm going to sub it in for that x. So it's -3 times 1 minus 3y. And we have the rest of our equation. Minus 3y is equal to -15. And now we need to solve for y. And again, this is the point where you need only one variable in there. There should only be either x's or y's. There should be nothing else. So distribute that -3. -3, -3 times -3 is positive 9y. Combine your like terms. 9 minus 3 is 6y. Then add 3 to both sides. -15 plus 3 is -12. Divide both sides by 6. Y is equal to -2. Once you have your y, plug that back in to find your x. So x is equal to 1 minus 3 times -2. -3. Now you could look at this a couple different ways to do -2 to get +6. That is equal to 7. Now if you, x is equal to 7. If you leave it like this, that's fine, where you have y is equal to and x is equal to. Just make sure you include the x and the y. Because if you just have equals 7, I can't give you full credit on that because I'm not sure what is equal to 7. So make sure you be careful with that. And again, as an ordered pair, that one would be 7, -2. If you were to graph those two lines, that would cross at 7, -2. Any question over those at all? All right, go ahead and do the next one on your own. I'll put up the answer here in a second, and then move on to elimination. All right, my work are up there. Sorry if I rushed you through that. So with this one, the weird thing, I said it's kind of a different answer, is you end up getting, we add 12 to both sides, you get 0, that's fine. Just keep solving like normal. Divide both sides by 27, 0 divided by 27 is 0. I'm getting x is equal to 0, plug that back in, you get y is equal to -2. Same thing I told you before with some other things. If you I would encourage you to check your work, but that's like always check your work, no matter what answer you get. So check your work, but yes, that's a fine answer. 0 is a number just like any other number. Any questions before we move on that? So the next one is elimination. So elimination is probably the most common one. Not that you guys are actually going to need to know this in this class, but this leads into matrices. But the best time to use this is when both equations are in standard form. Now, there are other times to use this. There's other forms you can do, but the time we use it most is when they're in standard form. Again, if they're not in standard form and you want to use this method, you could put them in standard form. It's completely up to you. So the way we do this is ultimately we want to have two numbers in our equation that are equal but opposite, which means they're the same number, one's positive, one negative. So number 5, we have +4, -4. We're sitting pretty good on that. If we don't have that, then we're going to need to manipulate a little bit. So that's what it says up there at the beginning. You multiply one or both equations by something, get equal but opposite variables, and then you combine those equations. When you combine them, the variables cancel. For this one is easier to get your first variable, but then it takes a little bit more work than substitution to find your second variable. For this one, we add these together. My 4x is canceled. Again, 4x plus -4x is 0x, which is this. 2y plus 5y is positive 3y. And 2 plus 25 is 27. So divide both sides by 3. You get your y value is 9 right away. But again, now we have to sub that back in. Now, it doesn't matter which equation you sub it back in for. I'm going to sub it to the top one. But again, they both should get you the same answer. That's kind of the idea. So we have 4x minus 2 times 9 is equal to 2. And again, a little bit more work than the last one to solve. Negative 18. 18, you get 4x is equal to 3. On both sides by 4, x is equal to 5. So 9 is after that. Now moving on to the next one, and this is the hardest it's going to be. Chapter review. I apologize because I hadn't changed my mind. I think it's number 10 on your chapter review, maybe. You have an elimination problem where you have to multiply one of them by like 2 or something. You're not going to have one like that on the test. On the test, the hardest one you have is one like number 6, where you have to multiply one of the equations by -1. Again, I could have gone further, could have gone into more depth, but I stopped myself and actually, again, changed some things because I thought, I just want to have the bare basics. We'll get onto that other stuff a little bit later. So, problem like number 6, you do not have numbers that are equal but opposite. You have them equal, you have a 2y and a 2y, but they're not opposite. Make them opposite, you're going to multiply one of the equations by -1. It doesn't matter which one you do, multiply the equation by -1. Some of you guys, you write that below here, and then you cancel things out and you do it like that. If you want to do it that way, you can. That is up to you. I'm going to highly encourage, and again, this is one of those things, like I said before, I'm going to highly encourage you to do it this other way. It takes a little bit more work, but it helps a lot of people. So that's what I'm talking about. Those of you who really are trying to figure out how you can either get an A+ in this class and not make any mistakes, or those of you who just are going to fight to get that 60%, I would go ahead and do this. This one is negative x minus 2y is equal to positive 3. Change, but it doesn't change. I'm still going to write it down. And again, this is what I'm talking about, where it takes a little bit more time, but now everything is there. Everything's nice, orderly. It's nice and organized. I should make sure I point out, make sure that -1 also multiplied by the 3. You multiply the whole equation by negative, and that means everything. The 5, the 2, and the -3. So now we have equal but opposite. Positive 2. So those will cancel. Negative 5x plus 8x is 3x. 5 plus negative 12 is 9. Negative 9. Divide both sides by 3. I get x is equal to -3. And then again, it's an equation. And it doesn't matter which equation. You can even use your new equation. That will work as well. Personally, would probably use the first equation here. But again, it's 6 in one hand, half a dozen in the other. All means the same thing. Times -3 plus 2y is equal to -3. Parentheses when I stuff in because it's 5 times -3. Add 15 to both sides. And divide both sides by 2. We get y is equal to 6. So x is -3, y is 6. And you can represent that as an ordered pair. Again, you don't have to, but if it's multiple, that's how it's going to be. So the last one, number 7, go ahead and do this one on your own. I'm going to give you a couple minutes to do this. Then I'll give you the answer. So my answer is up there. You can multiply the bottom equation by -1. You get it at the top. It doesn't matter as long as you go do both. The important step, you have a positive 6x and a negative 6x. Now, What we'll learn later is that you could have also multiplied the bottom by -2 and got your y to cancel. That 8y and -8y. That's what we'll go over. I mean, it'll be a couple chapters, but that's the other part of this.